Welcome one and welcome all to another Python programming tutorial. Today we are going to cover utilizing Python to fit curves to data. So I've already prepared a short Python script, and I'm going to kind of walk us through this and describe how it works. Alright, so starting at the top, we have a few import statements. These first two import statements are importing matplotlib in a way that works with my desktop. These are just little tweaks I've made to how matplotlib works with my desktop, and they are not strictly necessary for your environment, but if you have these two lines, then you'll end up producing plots the same way that I am. These next few lines are importing some libraries that we will use for plotting. First, we import matplotlib.pyplot as PLT. This as PLT piece here is giving a nickname or an alias to the matplotlib.pyplot library. So this allows us to type PLT instead of matplotlib.pyplot. So that saves us some typing. In principle, we can change the text after the as to whatever we want, but commonly people use PLT for this import. Next, we're going to import NumPy. NumPy is a great numerical Python library, and we will also set this import up as NP. And we will also be utilizing scipy.optimize's curve fit function to fit our data to a curve. So first, let's take a look at our data. Now, I don't have any fun experimental data currently handy, so I've just created some simulated data. So here we define np.linspace, and we will get values from 0 to 100, and that will be our x data. Then I wanted to generate a little bit of noise, so this samples from a normal distribution using np.random.normal with a mean of 0 and a standard deviation of 2, and I will generate the same length of x points, so the same number of x values. I'll generate that many noise values. That's what's going on here. And then I will just give this data a little bit of a linear scaling by multiplying x by 3, adding 5, and adding my noise. So let's take a look at some of these. Let's see what this looks like. So we're going to plot the x data and x. So this should be a nice line, and we will label this as our x. And let's also plot x and our simulated data. And we will give this a label as well. We want this legend to show up. And let's save this as simdata.png. And I've got some code that we'll cover a little bit later. So I'm just going to now call the script to exit so we don't end up running that. Alrighty. Okay, so here we can see when we plot x as a function of x, we get a line with an intercept of 0 and a slope of 1. And if you look at our simulated data, we can see that it's not a perfect line and it's got a few bumps. So our simulated data is the data that we're going to now attempt to fit with a line. So let's jump back into our script, and I'm going to just delete some of this kind of debugging pieces here. All right, so we want to fit our simulated data with a line. So the first step in fitting curves using scipy.optimize's curve fit function is to define some function, define the curve. So here I've created a Python function called func that accepts x, m, and b as a parameter and returns x times m plus b, which is our familiar y equals mx plus b, the equation for a line. So this is the function that we are going to be fitting our experimental data to. So in order to use the curveFit function, there are 3 required arguments. The first argument is the function, which is the function that you want to fit the curve to. So here we're fitting it to y equals mx plus b. So we're passing in the function that that's the functional form of what we're trying to fit. So if we wanted to fit our data to an exponential curve, we would change these parameters to have an exponential equation in them. Then we pass it our x and our y, which in this case, our x data is x, and our y data here is simulated data. So this is the data that I've added the noise and the linear shift to kind of make things interesting and see if we're able to fit this. Now, curveFit returns 2 arrays. And I've stored both of these arrays in a variable called params. Now, the first array that curveFit returns, which I can access with params 0, is the coefficients or the inputs to the function. So when you pass in function, your x and your simulated data, or your x and your y, and then access params 0, we will get coefficient m and b, which are the coefficients that it guesses or that it fits into our equation. So you receive as many outputs here as you have inputs into your function -1 because you don't receive the x values back. Now, the second array that's returned with curveFit, which you could access with params 1, is a matrix of essentially how well your curve fitting function does. It's the estimated covariance. That's right. It's the covariance of the fit. In a later tutorial, I can cover what that means and how we can extract R squared and how we can measure how well things fit. But for now, we're just going to worry about the coefficients that it spits out, and then let's just print them before we plot them, and let's see what they look like. Oop. It's important to spell Python correctly. All right, so our M is like 2.9 and our B is 6.4. So close-ish to how we scale things with our simulated data. And let's see what this looks like. Now, we're now going to plot our we're going to plot our fit. And in order to plot our fit, we take we plot our x data, then we plot our x data times our m that we get from our curveFit plus our b that we also got from the curveFit. So now this is transforming our x values into y values by using those parameters that we got from our curveFit. Let's also plot our original data. We'll label this. All right, and as you can see here, our fit is pretty good, where we have our orange data, which is the simulated data, And then our fit is this blue line that's plotted behind the orange line. So that makes it a little bit harder to see. So why don't we go ahead and give this some transparency. All right, so now it's a little bit harder to see the sim data, but that's okay. This lesson isn't a lesson on great ways to visualize data, but instead just how to do some basic curve fitting. So now you can see how our fit looks pretty good. We've been able to fit a line to our simulated data, which if this simulated data was something like a velocity curve or a displacement curve, we could then use the slope, or we could integrate this line to be able to calculate other kinds of properties. So fitting data in curves with Python is nice and useful, and in my next tutorial we will cover how we can then take a function, integrate it, and calculate its gradient. Thank you.